is a superhero who must save the world by throwing a pig on top of Coog's residence as a sacrifice to the invading aliens. If he is 43 meters from the building when he throws it, what speed and direction must Pete throw the pig to reach the alien Neil? The building is 75 meters tall, and Neil is 13 meters into the building.
One of the first things you have to do in a physics problem like this is decide what kind of problem are we really solving here? Is it an energy, dynamics, momentum, or kinematics problem? Well, we're supposed to find the initial velocity and the direction that Pete throws the pig at. So we can automatically cross out dynamics and momentum because we don't have enough forces to draw a free body diagram that would give us relevant information, or neither do we have any collisions that occur in this transaction. Energy would give us the final velocity and the initial velocity, but it wouldn't necessarily give us the direction that we have to throw the pig. So let's just use kinematics. We know that Pete is 43 meters away from the building, but we also know that Neil is 13 meters inside the building. So our total change in the x direction is going to be 43 plus 13 meters, which is 56 meters. We also know that the building is 75 meters tall, so our change in the y direction is going to be 75 meters. We know the acceleration in the x direction is going to be 0 because there are no forces acting upon Connor, our pig, that we're going to sacrifice. But the acceleration in the y direction has to be the force of gravity, which is negative 9.8 meters per second. In fact, let me just draw the compass right quick right here. This will be our positive x direction. This will be our negative x direction. This will be our positive y direction, and this will be our negative y direction. So acceleration in the x is 0 meters per second squared, and acceleration in the y is negative 9.8 meters per second squared.
And do you know the final velocity as the pig reaches Neil?
Right. We also know that the final velocity of Connor, the pig, as he reaches Neil is 0 meters per second in the y direction. Kinematics problems is that you can break up the components of velocity into the x and the y direction. So if we were to solve using our kinematic equations in the y direction, we would get a value for time that we can also use in the x direction. Let's go about this way to solve this problem. So we can use the equation 2 times the acceleration times the change in distance is equal to velocity final squared minus the velocity initial squared. Now in order to solve for initial velocity, we just push the velocity final on the other side and we get this equation. The square root of 2a delta t d minus velocity final squared. And I guess you didn't catch my mistake here, because velocity initial is actually velocity final squared minus 2a delta d. So let me just fix that right quick. That's better. Now, let's plug in some values here. And we find that our initial velocity in the y direction, so this is obviously about 38 meters per second. And now we know our initial in the y direction. Time is about 3.8 seconds. Now we know the time in the y direction, so now we know that the time in the x direction also has to be 3.8 seconds, about. Now let's solve this equation in the x direction. Now we know that velocity is equal to change in displacement over time, and so plugging this in, we get about 14.7 meters per second. In order to get our direction that we need, we can simply note that the theta in between this angle is the same as the ratio of velocity x over velocity of y. These things are related by the equation tangent theta is equal to velocity initial x over velocity initial y. Theta is approximately 21 degrees. that will be our direction. And we know that velocity initial is equal to the square root of velocity initial in the x direction squared plus velocity initial in the y direction squared. So we get an initial velocity about 40.1 meters per second squared. Meters per second. So we know that Pete has to throw Connor the pig in order to save humanity from the world to the alien Neil with the initial velocity of 40.1 meters per second squared at 21 degrees above the negative x horizontal.